All right, we are given some information about the derivatives of some function. And we know that the Maclaurin series converges for -1 to 1 here. Absolute value of x is less than 1, which means that it's centered around 0. We want to show that the first 4 non-zero terms are x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4. Everybody good? Yeah? So what do? First thing we need to do is we need to show that, well, if f of 0 is 0, that first term should be 0. Well, that's given to us. F prime of 0 ought to be 1, so that should be 1 times x over 1 factorial. So that's going to just be x, right? Then we need to show the coefficients for n equals 1, n equals 2, n equals 3, n equals 4, and so on. Right? So as we go in and we do that, our second derivative when n is 1, second derivative at 0 should be, what should be? Should be -1, and then it should be times the first derivative at 0, which is 1. So it should be -1 times 1 for that coefficient. And then we end up with, that should be over a 2 factorial, which is just the 2. So we have minus x squared over 2 factorial. Clearly, that's the same thing. The next one, f triple prime, which would be when n is 2, should be -2 times the second derivative, which was -1. So that should give us a positive 2 x cubed over 3 factorial. And the 3 factorial is 3 times 2, that's 6. 2 sixths is a third, so that gives us 1/3. And then our fourth derivative should be the opposite of this. So that should be -3. And then it should be times positive 2. So that's 6. So we should end up with a minus x to the 4th, 6x to the 4th over 4 factorial, which is 6/24, which is 1/4. And so that should show that all of those are correct. Everybody good with that? That was worth, wow, that was worth 3 points. That's exciting. Oh, and write the general term. We didn't write the general term. What should our general term end up being? Everybody good with that? Or no? That's what Noah said. Are we good with that or not?
I think it's I started at 1, but I think it's fine.
You started at 1, but you think it's fine.
So it would be -1 n plus 1 minus x later on.
Yes, this is a better option here, because we're talking about, if we're talking about n values here, this is the value when n was what? When n was, I'm sorry, not this one. This was the value when n was 1. This should be the value when n is 2, n is 3, n is, oh no, actually, yeah, either way is fine, I guess. -1 to the n plus 1 x to the n over n, or -1 to the n x to the n plus 1 over n plus 1. Either one is good. So they gave you 3 points for that. 1 point. 1 point for finding all of these derivatives, 1 point for verifying the terms, and 1 point for your general term. And then we want to know, does this thing converge absolutely, converge conditionally, or diverge at x equals 1? So at x equals 1, what does this series look like? This should be just -1 to the n plus 1 over n. And this we know converges how? Conditionally, absolutely, conditionally. And our reasoning ought to be that it converges because it's the alternating series test, but it does not converge absolutely because that fails the p-series test. No, you don't need to prove that the general term is it. They just want to see what it is. And then they gave you 2 points. 2 points for saying that it converges conditionally with a reason. So you like the alternating series test, but absolute value diverges by p-series. My handwriting is bad, but that's negative. The absolute value of -1 to the n plus 1 over n diverges by the p-series. Everybody good with that? Y'all hear it? People in the Zoom, y'all good with that? 5 points from parts A and B. Part C, we're going to write the, what? Did somebody say something? I thought somebody said something in the Zoom. No? It was sorcery. All right. Apparently so. All right, part C asked us to write the first 4 non-zero terms and the general term of the Maclaurin series for g of x, which is the integral from 0 to x of f of t. So if we're going to write the first 4 non-zero terms, we need to integrate this series from 0 to x, which means we need to integrate each of these terms term by term. So what should the first one become? Should become x squared over 2. The next one should become minus nx cubed over 6. Next one should become, and the next one should become over what? 20? Sounds good to me. Everybody okay with that? Or no? Let's see, they gave you 1 point, sorry, we'll give you 1 point for the first 2 terms. They gave you 1 point for the other 2 terms. And then they gave you 1 point for the general term because it asked for the general term also. What was your general term? I think it asked for the general term, right? Yeah. Still -1 to the n plus 1. That's your general term. And that's 1 point. Everybody good with that? Right. And if you wanted to be a little bit more explicit about this, we're integrating this from 0 to x. So, you know, this would be, if we did this as a definite integral, which is sort of, as an indefinite integral, which is sort of how we did it here, we'd have a plus c, and that plus c would end up being 0 because we'd evaluated at x, which would give us this, and then we'd evaluate it at 0. So, like, you know, should have written it this way, probably. The integral of this from 0 to x, right? You plug in x when you integrate, and then you plug in 0, and every term when you plug in 0 is just 0. So that's why you get that, right? Everybody good with that?
Sorry, how did we get the n plus 1 on the -1 in the general term?
Well, it was in our original one. And that's just a constant, so that doesn't change.
Okay, never mind, sorry.
Does that make sense? Yeah.
I don't know why, but in my answer I have -1 and -1, but that's the same thing, right?
Same thing, wouldn't matter.
Okay, so I wrote a -1 in the general. Is that's not going to be it shouldn't be an issue, right?
What do you mean you wrote a -1? You wrote in -1, you mean?
Yeah, n minus 1 for the general term in A, and then I kept it.
Oh, yeah, that's fine. Yeah.
Okay, all right,
Yeah,
gotcha.
that'd be fine. Yep. They're exactly the same thing. Cool. All right, and then what did it ask us to do in part D? Something about error, I think, right? Yeah, so p sub n at 1/2 is the nth degree Taylor polynomial at x equal to 1/2. G is the function that we've defined in part C. And so we want to use an alternating series error bound to show that the fourth degree Taylor polynomial at 1/2 minus the true value. So this right here, this piece right here is our error. So effectively, we want to show that our error is less than 1/500. And so if we're talking about a fourth degree Taylor polynomial at 1/2, our error should be less than or equal to the next term, since it's the alternating series test. So that should be the term with the fifth degree in it. So that should be less than or equal to the absolute value of 1/2 to the fifth over 20, which is, what is that? 32 times 20 is 640, 1/640. And what were we trying to show is less than 1/500. So since 1/640 is less than 1/500, our error that is less than that must be less than 1/500 as well. And that was worth 1 point. Any questions on that one? You okay with that, Noah? You just needed to show that your error was the next term. Then you needed to show what the value of that next term was. And then you needed to state that that value that you got was already less than the value they wanted to show that it was less than. So since you know the error is less than this thing that's less than what they wanted to show, your error. No. Yeah, so that would be wrong. So when it says p sub 4, that's the fourth degree Taylor polynomial. So that's up to the term that has a fourth power. Not 4 terms of it, not 4 non-zero terms, but the one up to the term with the fourth degree. Does that make sense, everybody? When they say the fourth, where is it over here? When they say the fourth degree Taylor polynomial, that means fourth degree, not 4 terms. Zoom, you're good with that? I think the people here are good with that now because I explained that to Noah. But everybody good with that?
Yep.
All right. Wonderful. Okay, then we had another one. I think I asked you guys to do this one as well. Yeah? Okay. So we are given, they give you the series for natural log of 1 plus x. They want you to write the first 4 non-zero terms and the general term for x times natural log of 1 plus x over 3. So what are we doing with that? We're replacing the x, every x with an x over 3, and we're also multiplying it by x. Everybody good with that? So what should the first term be? We're going to replace the x with an x over 3 and then multiply by x. That first term should become x squared over 3. Everybody agree with that? Second term should become minus x cubed over 18. Next term should become plus x to the 4th over 81. And you don't have to simplify out each of those. Next term would become x to the 5th over, I don't know, what does that come out to be? Did they write it? They didn't write it in here. I don't know, what's 80, what is 81 times 4, right? So 324. Yeah. Everybody good with that? Yeah. And then your general term should have been negative 1 to the n plus 1. Instead of x to the n, it should be x over 3 to the n. So x to the n over 3 to the n times n. And they gave you 2 points for that. 1 for the general term, 1 for the other 4 terms. Good or no? Zoom, you guys good? Zoom good.
Zoom good.
Zoom good. Good Zoom. We have everybody here today. 34 participants in Zoom, which includes me. So that's 33 students plus 3. But everybody's here. That's great. All right. So part B says determine the interval of convergence for F. So what are we going to do to determine that convergence? For part B, what are we going to do? I suggest we use the ratio test. Yeah. Look for a limit as n approaches infinity of, let's see here. No matter what x is, are these all positive terms? Nope. So we'll take an absolute value. And we've got -1 to the n plus 2 times x to the n plus 1 over 3 to the n plus 1 times n plus 1. Times the reciprocal of that, which should be 3 to the n times n in the numerator. And in the denominator, I wrote plus 1, I should wrote plus 2. -1 to the n plus 1 and x to the n. Everybody good with that? That's your ratio. Limit as n approaches infinity. Let's see, the -1 to the n plus 2, the -1 to the n plus 1, those are all just 1s and -1s, and those, when you take the absolute value, are all just 1s, so those don't matter. X to the n plus 1 over x to the n is just x. The n just stays. The 3 to the n plus 1 and the 3 to the n in the numerator just becomes a 3 in the denominator, and then the n plus 1 stays in the denominator. And what is that limit as n goes towards infinity? X over 3. Everybody good with that? Set that less than 1 to determine that the absolute value of x is less than 3. Tells us that our radius of convergence is 3 and that it converges for -3, 3 as our base interval of convergence, and it has absolute convergence on that interval. Everybody good with that so far? Okay. To get to that point, if you got to that point, you got 3 points. So 1 for setting up the ratio, 1 for finding the radius of convergence. Did it specifically ask for the radius of convergence? No. Okay.
No.
Yeah, 1 for getting to this absolute value of x that was less than 3. And 1 for the limit and 1 for the absolute value of x is less than 3. So 3 points up to that point. Then you need to check your endpoints of -3 and 3. So at x equals -3, the series that we are then looking at becomes, if x is -3, this is -1 to the n plus 1. -3, well, we'll write it as -1 to the n, and then we'll write it as 3 to the n. And then in the denominator, we have a 3 to the n, and what else do we have down there? Just an n. And what cancels there? 3 to the n and a 3 to the n, so it's kind of an n in the denominator. We have -1 to the n plus 1 and -1 to the n, which should give us -1 to the 2n plus 1, which is, well, yeah, if you think about that, you plug in any values for n. If n is 0, that's +1. If n is 1, that's going to be 3. If n is 2, that's going to be 5. These are always going to be odd, right? These are going to always be negative. So n equals 1 to infinity of -1 over n. And what do we know about that? It diverges by the p-series test. Should write the word test. Yeah, diverges by the p-series test. Everybody go with that? Okay. What about the absolute value at x equals -3? So what about the absolute value at x equals -3? Well, that's going to be this whole thing inside absolute values, which is just going to become one over n, which diverges by the p-series test, right? So we know that it does not converge, nor does it converge absolutely at x equals -3. Good? Clearly, I mean, if it didn't converge, it wasn't. Anyway. All right, what about at x equals 3? We've got what? Sum from n equals 1 to infinity of negative, was it -1 to the n plus 1, right? 3 to the n over 3 to the n times n. Is that right? I can't remember what all we had written. Yep, looks like that's right. Which becomes what series? The sum from n equals 1 to infinity of -1 to the n plus 1 over n, which converges, that time by the alternating series test. Everybody agree with that? And then our absolute value at x equals 3 should just be the sum from n equals 1 to infinity of 1 over n, which diverges by the p-series test. And so our final answer should be that this converges -3 to 3, inclusive on the 3. And I assume it's specified when does it converge absolutely. Converges absolutely, -3 to 3, non-inclusive, and conditionally only at 3. And let's see. Okay, I guess it didn't actually ask all of those things. It just asked what's the interval of convergence. So your answer was just this. That other stuff's good too. Sometimes they ask that other stuff. And so your last 2 points for that problem were, did you consider both endpoints? That's 1 point. And your final interval of convergence is the last point. So that part was worth 5 points. Good or no? Feel okay about that? And then you went to sleep?
Yeah. With the timer still running.
Oh, perfect.
I woke up and I was having a problem.
And you still didn't finish it?
Yeah.
What a disappointment. All right, part C, alternating series error bound. So let P sub 4 be the 4th degree Taylor polynomial for f at 0. Use the alternating series error bound to find an upper bound for this error. So alternating series error bound says that it should just be the next term. So our next term is this x to the 5th over 324. And we're trying to do this at 2. So this ought to be 2 to the 5th. Our error ought to be less than or equal to 2 to the 5th over 324, which, I don't know, what does that simplify to? Eight over 81. Oh, that's good. I got it right. There's your bound on the air, 8 over 81. 1 point for using the 5th term, 1 point for the answer. So 2 points for that. Pretty generous for them to give you 2 points for that. Good? Any questions on that? All right. How are we feeling about the series FRQs? Okay? Not okay? Not okay, Derek? Should we look at some of the area volume ones though? Yeah, since we're gonna have some of those on the quiz tomorrow. We should probably look at one. All right. Yeah, didn't I say that? I didn't say. Oh no, the quiz is just on the regular stuff, right? That's what I said. Good thing I haven't made the quiz yet. All right. In that case, let's do one. Should we do one more series? What do you think? One more series one? Or no? Are you going to be really upset if we do one more series one first, John? No? All right, we'll do one more series, then we're going to talk about the area volume ones. Have you guys done this one yet? No? All right. It's the last one in that 2015 to 19, so it's the 2019 one. All right, so I'll give you guys about 15 minutes to work through this and we'll go through it. Then we'll try to take a look at one of the area ones. Can you read it okay, Jenna? There's a glare. I could close the door, that would help maybe, but I'm not supposed to do that. We could put Derek in charge of the blinds again. Okay, well, now we're recording again. So A and B were pretty straightforward. Hopefully you're good with them. Okay, good. All right, part C. What about part C? What do we need to do? We needed to integrate from 0 to x our function for f of t. And then we want to use the Taylor polynomial that we found in part A to find an approximation for h of 1. So if we're going to integrate, what did it say? Integrating, what are we integrating? F of x or e? Yeah, not e to the x f of x, just f of x. Okay. So we're integrating from 0 to x f of t dt. So what are our terms as we integrate? I don't have them in front of me, so somebody just tell me what you got, and hopefully they're right. What is it? Yeah, after you integrate. (23x to the 4th over 48). Does that look good to everybody? I guess I can look at the score and get it. 3x minus x squared plus x cubed over 2. Yep, you did your arithmetic right. So that's your series. We want to evaluate that at 1. So it was 1, right? Yeah. So 3 minus 1 plus 1/2 minus 23/48. And that came out to be 97/48. Everybody good with that? 1 point here, 1 point here. Any issues there? In Zoom, you guys good or no?
Good.
All right. Then part D said we know that H converges, the series for H converges for all real numbers. It's known that they alternate in sign, they decrease in absolute value. Use the alternating series error bound to show that your approximation from part C differs from H of 1 by at most 0.45. So that means we are going to need to use the, since it's an alternating series, we're going to need to use the next term. So what is our next term there for H? So our next term for F, specifically for F, would have been 54 times x to the 4th over 4 factorial. Right. And so then when we integrated that, we should have got 54x to the 5th over 5 factorial. So 54x to the 5th over 5 factorial. We were talking about at 1, is that right? So just 54 over 5 factorial, which is 54 over 120. Which is what? Is it 0.45 exactly? Great. Good? Good. Not good. Good.
Can I ask
Great.
a question about B?
About B? Sure.
So could you explain why you didn't just multiply the two series term by term?
That's what we did do. 1 times the 3 gave you 3. 1 times the negative 2x and 3 times the x. I mean, yeah, it's just, it's distributing, right? It's this thing times this thing.
Oh, wait, I thought it was like 3 times 1, and then the next term would be negative 2x times x.
No,
Yes,
no.
yeah.
Yeah. You're distributing the, like, what do they call it back in algebra? Foiling. You're foiling.
Okay, yeah, thank you.
Yeah. Yep. And then part D there, they gave you 3 points for that. So 1 point if you did what we did here to find the 54 x to the 4th over 4 factorial, 1 point for this, and 1 point for this. Yep. Good? How do you get that decimal? Easiest way is to just, I would reduce this. So if I could divide this by 6, this is 9 over 20, which would be 45 over 100, 4,500. Yeah. Fractions and decimals are cool that way. How are we feeling? We're feeling better about series? Does that one go okay for everybody? Question on part A? Yeah, that's from, so remember it's f of 0, that's the 3, right? F of 0 is 3. Then it's f prime of 0, which is the slope. So if this is the tangent line to it, the slope of that tangent line is negative 2. Any other questions there? Anybody have questions on that problem? You're all okay with that problem? All right. Cool. That's good enough for series stuff for today, I think. Let's take a look at the area volume FRQs. Did I ask you guys to do some of these already? I did? The first 2? Okay, so I already asked you guys to do this one. All right, then let's take a look. This was a calculator one. All right, and we are looking for the area of X. Right, so
You
guys
can
see it?
only see the series question still.
There you go. Now you're good?
Yep.
All right. So they're asking you to find the area of S to start with. Well, that should be pretty straightforward. You need to use the formula for the area of a polar function. What's the area of a polar function? It's the integral of 1/2 from 0, in this case 0 to root pi, because that's what they tell you the bounds are, of your r squared. So 3 root theta sine theta squared d theta. And this is a calculator question, so just type that into your calculator and get an answer. Your answer was 3.534, I hope. Does that sound good to everybody? You did not do this problem, Noah? That is shameful. Yes. 2 points for this, 1 for the integral, 1 for the answer. So that should have been pretty straightforward. Anybody questions on that? Jenna, is that what you got when you plugged it in? Yeah. People in Zoom, you're all good there?
Yes.
All right.
You know what number this is?
What number this is? It's the 2019 test. It was problem number 2. All right, part B asking for the average distance from the origin to a point on the curve. Well, the distance from the origin to a point on the curve is just that function, right? That's the distance. That's how we define this. That's the R value. R is that distance from the origin to the curve. So if we want the average distance, that's the mean value theorem for integrals. So that should be 1 over root pi minus 0 times the integral from 0 to root pi of, and I'm not going to write that whole function out again, r of theta d theta. And that came out to be 1.579933. And that was also worth 2 points, 1 for the integral and 1 for the answer. Does that make sense to everybody there for part B? Okay. All right, part C is where things get a little more complicated. It says there is a line that goes through the origin that has a positive slope of m that is going to divide region S into 2 regions with equal area. There it is. There's my line. This has a slope of m. Okay, I don't know why I drew an arrow to it. We want to write, but we don't need to solve an equation involving one or more integrals whose solution gives the value of m. So how are we going to go about that? First off, it's half the area, right? So that means that whatever our integral is going to need to equal 1/2 of 3.534, because that's the full area. Right. And so then we need a formula to represent the area from 0, let's say, to whatever this theta value is. Right. How are we going to figure out what that theta value is? What do we know about this? This has a slope of m. True? Well, what is a slope? The slope is a
Y over
change
X.
in y over a change in x. Well, if we want to figure out what angle that is, how do we figure that out? If it's a change in y over a change in x for this angle, theta. Yeah, it should be the inverse tangent of this y over x. And theta should be the inverse tangent of that slope. And we don't know the slope, so we don't know the inverse tangent of the slope, but we can set up the integral as 0 to inverse tangent of m of r of theta squared with a 1/2 out in front. Yeah. Good or no?
Do we have to solve for m, or like? 'cause
No,
it
you do not
says
need to. There's no way to solve for m.
whose solution gives the value of m, so we just have to have m in there.
Yep.
Okay.
Correct.
And we don't need to write the other one where we go from inverse tangent of m to the square root of pi. It's good enough to just show one.
Correct. Yeah, I mean, you could if you wanted to. You could do 1/2 of the integral from 0 to inverse tangent m of r of theta squared equals inverse tangent of m to root pi, or 1/2 of that integral. That'd be fine. But since we already knew the full area of S, then you can just use 1/2 of 3.534. Uh-huh. They showed out the y over x? What do you mean? Oh, let me look here at the score. Equates polar areas, inverse trig. The guideline says inverse trigonometric function applied to m as a limit of integration. So, I mean, I think if you just wrote that I don't think you need to show that. I don't think you need to write tangent theta equals y over x, which equals m. Doesn't hurt, but I don't think you would need to. Yeah. Any other questions there on part C? Okay. All right, now for part D, let k be greater than 0, and A of k is the area of the portion of region S that is also inside the circle R equals k cosine theta. And we want to find the limit as k approaches infinity of that area. Well, what do you know about the circle R equals k cosine theta? That's a circle over here in the first and fourth quadrants, right? With a, as k gets bigger, the circle gets bigger. K gets smaller, the circle gets smaller. So as k goes towards infinity, what's happening to this circle? Getting infinitely large, and it should be basically enclosing everything in both the first and the fourth quadrants, right? So if we are looking for the area of S that is also inside this circle, as k goes towards infinity, this circle is going to take up all of the area in the first quadrant, meaning that all the area we're looking for is whatever part of S is in the first quadrant. So the area of S in the first quadrant ought to be 1/2 the integral from 0 to pi over 2 of R of theta squared d theta, which should come out to be 3.324. And they gave you 2 points for that, one for having the right limits of integration and one for the right answer. With having it, and you needed to show the integral setup also. Oh, and for part C, it was 3 points. One for making an equation that set up with the polar areas, one for having this correct upper limit, and one for like both sides of the equation being correct. Does that make sense to everyone? Any questions there on that one? All right. And I also asked you guys to do this one, right? That's the other one I asked you guys to do. We obviously don't have time to go through that today. So that'll be the first one we go through on Monday. We'll do it on Friday if we have time after the quiz. And then I'd like you guys to try and complete the next couple of these of the area volume, because that's what we're going to start focusing on next. So at least do numbers 3 and 4 from the area volume. 3 and 4 from the area volume. Other than that, I think we are good.